Hello everyone and welcome to yet another recreation programming session with Mr. Azozin. So today we're going to be looking into an interpreter which is called picoc, but people told me that it's supposed to be pronounced like picoc, but in my mind I already pronounced it like picoc, so I'm going to be pronouncing it picoc for the entirety of the session. So it's basically a very small C interpreter for scripting. And what caught my attention is that it literally tries to be C programming language, or like it's trying to be compatible with the C programming language on a source code level. So there were a lot of C-like interpreted languages in the past. Like I remember there was a Pike programming language, right? But they were kind of like, you know, mimicking the vibe of C, but they were never really compatible with C, right? So they're like a C-like programming languages. This is the website and doesn't even have any examples or anything like that, so fuck that. So, but this one is like literally trying to be a C interpreter. So, and I suspect that you can take like a literal C code and maybe probably interpret it. So, and that's what we're going to be looking into today, right? So I just want to take a look at it. So unfortunately, it's kind of abandoned. Right, so as you can see, so 10 years ago, I suppose the latest change was actually made 8 years ago. And furthermore, it was brought to my attention by Kamikaze that it's actually a fork. It's actually a fork from this repo, and you can actually clearly see that from the amount of stars, right? So the one that I found on Google, right, so I just Googled it up, has like 437 stars, but this one, the fork, has 1.5k stars, which indicates that people knew about this thing earlier, so it accumulated more stars over time. But then at some point it got moved to GitLab, and on GitLab it doesn't really have that much star because GitLab is a much smaller platform. And what's funny is that it wasn't really developed that much since then, right? So we can even take a look at that. So look at that. On GitHub, it has 557 commits, and on GitLab, it has 556 commits, one commit less, which probably indicates that that extra commit in here is literally removing the entirety of the source code and just pointing to the GitLab. And then it wasn't developed since then. But then the fork has 693 commits. But they all stopped developing roughly at the same time. So it's kind of weird what is going on in here. So stars is a real vendor lock-in of GitHub. Yeah, exactly, right. So because like it's kind of the only reason why people actually use GitHub is because of the outreach of the platform, right? So in its you know, so sort of like a social media capabilities and stuff like that. So you can just put something on a GitHub. It even has a recommendation algorithm. So some people will just naturally stumble upon your repo, and it just like gives you great exposure. Like you don't really need GitHub if you just wanna, you know, host some private repos. You can do that over SSH server. But anyway, so I'm not quite sure like which one to pick in here. Both of them are dead, right? So we might as well actually take a look at the original one, right? So let's take a look at the original one. I'm gonna literally just clone it. So yeah, let's do git clone. And do I want to do a shallow clone or a full clone? Let's actually do a full clone. Let's go into the third party, right? So, and I'm just gonna clone the entire thing. Let's fucking go. Let's fucking go. So yeah, that was relatively fast. So here it is, and we can even take a look at the commits. Right, so there you go. So this is the last commit. Essentially, it's actually two commits. Look at that. So it updated the README, right? It updated the README pointing to here, and then it also deleted the entirety of the source codes. So what's interesting is that we can probably add GitLab as one of the remotes. So I'm not sure which one I want to use. Maybe HTTPS. I don't remember if I have the SSH key for GitLab on this machine, but so let me add GitLab remote, and that's basically the thing. Not push that. So let's see. Yeah, I couldn't do that. All right, so let's remove the GitLab. So I don't have a SSH key in here, but we can try to just add HTTPS. Right, I'm going to be doing that. Add GitLab, boom, boom, not make it default. Let's take a look what's going on, and there you go. So, and then we can take a look at the history, right? Okay, so that's pretty cool. So here is the GitHub, right? So 2 extra commits, and then on GitLab, starting from here, it edits. Okay, so the reality was a little bit more nuanced, right? So they fixed a minor build issue just by providing a thing in here. So, and I suppose this one, it just continuing developing even further. We can even add that one as a remote as well. So the ability of the Git to just do this kind of thing is kind of amazing, honestly. So I'm going to add this thing. So it's going to be GitHub. Let's call it fork, right? So this is the fork, and we can just add this fork. Let's not make it like this. So updating fork, there we go. And there's a lot of things in here. So there were extra releases in here. Okay, so what I'm looking at, so this is the origin. Yeah. So when this is a fork, and fork goes, how much down does it go? All right, so it goes starting from here. Starting from here, it feels like it got forked right about the same time the original one got moved to GitLab. So, not quite sure what happened. It feels like some sort of a fallout of some sort of maybe conflict or something like that. I have no idea what happened in here. I'm just seeing a crime scene, right? So this is just a crime scene. Something happened in here. Both of them abandoned, by the way, right? Something happened 8 years ago, and we are just seeing the consequences. So I'm not really sure what to make out of that. So maybe I'm gonna look at the original one before the fork, right? So I think it kind of makes sense naturally, right? So I think it kind of makes sense. So we're already kind of looking at it. Let's just see. Might as well maybe, so GitLab, that's the one where they fixed the original version. Okay, so this is a master GitLab. There we go. So here it is. So now, how do you even build this entire thing? So we have a make file, right? And I'm gonna just presume that you just do make. And it seems to be compiling. There's some minor warning, but apart from that, it just compiled. So, and I suppose a lot of these things are sort of independent. I can probably build it in 16 threads. So let me actually rebuild everything from scratch. Yeah, so you can build the entirety of this project in 300 milliseconds, roughly. Right? So if you do that in parallel on a machine with the 16 threads, right? So that's pretty cool. Okay, so what did we get? We got a lot of things. Is there any executables? I don't quite see. So here is the picoc, right? That's picoc. Okay, so if I take a look at this specific thing, what it depends on the read line and also in curses, so that means we're going to have a very good experience with REPL, right? So that means it supports maybe some, bash key bindings and stuff like that. Maybe it's going to have a history and stuff like that. So let's go and just start the entire REPL and see what it's capable of. Oh. So it doesn't just start into interactive mode, you have to specifically provide an interactive flag. Okay, that's very cool. Can I do 1+1? Parse error. Very nice language. Do I have to do a +1 semicolon? No. All right, let's try to do a hello world. Can I do a hello world, a C-style hello world? Thank you. That is very cool. That is very cool. It couldn't do 1+1, but it managed to do printf. And I have no idea why it couldn't do 1+1, because it's a valid C, honestly. Honestly, it is a valid C because it's an R value, but we're using R value as a statement, so it should just work, maybe. So does it have a history? Okay, I'm like pressing up and down. It does have a history because it integrates with the read line, which is super nice. So can I have a loop? Right. So if I do some unfinished statements, how is it go? Okay. Okay, it allows me to actually do things. It doesn't really allow me to go back and edit this line, unfortunately. Like, for example, Python, right? So do you guys know that in Python, at least in the latest one, you can do things like, I don't know, like 10, right? So, and I think yeah, I think it allows you to actually go back in here, so you can do something like this, and then you decide, oh, okay, I actually want it like up until 20, and only then do it like that. So it's kind of convenient, right? So in the latest Python, you can do that. I think you could always do that, right? So, but I mean, for something like a C interpreter, it will be also kind of nice because you can have very complicated statements. 1, 2, 3, 4. So this is going to be printf, and maybe I'm going to put D in here. So this is going to be hello world. A new line like that, so I'm gonna put I like so, and all right. So I need to process a little bit what just happened. Just a second. So that is very interesting. So I wrote this line, it parsed it but didn't execute anything. Then I wrote one statement within the body of the loop. It executed that statement, right? But then it didn't loop because it like doesn't know where this thing ends. What that means is that I can probably add another statement in here, so it doesn't just accumulate the entirety of the statement. It literally executes even sub-statements as I define them in a REPL. That is kind of crazy, which is also kind of cool, honestly, right? So if I do something like this, right, it will also print that new line, but up until I put the closing curly brace, it's not going to start looping. And yeah, it's not going to even execute that because I is out of the scope, and it probably doesn't support this variant of C where you could just have I defined in here. So it's immediate, yeah, that's kind of interesting. So that means I first have to, well, I mean, it's kind of nice for a scripting language that you have to declare your variables first. Right, so let's declare I. So now we have I. All right, let's try this experiment one more time. We're gonna start from 0 up until 10, plus I, right? So there you go. 1, 2, 3, 4. I'm gonna do printf. D hello world /ni. It executes that. I'm gonna add another statement in here, 1, 2, 3, like so. It executes that, and then I'm closing the loop, hoping I is still. How am I supposed to even organize a loop? Because like, can I assign I? I couldn't assign an I. So if I define it like this, I've no idea. Is that a bug? Is that some sort? Can you close the block? Close block. Didn't I already close the block? Maybe write int at the top of the line. What are you guys talking about? What are you all talking about even? Close the block. The block is closed. Put int I at the top. Here it is at the top. What are you all talking about? You don't make any fucking sense. Anyways, so let's take a look at some README stuff. Chat is hallucinating. They're just saying bullshit. Anyway, so oh, this is interesting. So it was originally written as a scripting language. Sure. UAV's onboard flight system. It's also very suitable for other robotic embedded and non-embedded applications. All right, that's pretty cool. There's not that many examples in here, unfortunately. Examples. And maybe this is why it got forked. Right, maybe this is why it got forked. So we can try to maybe just go into the fork and see if that fork performs any better, right? At least in that fork, it has like a README that seems to be markdown, and it has a bunch of examples. And okay, so I can already see that. Yeah, for example, here, as you can see, you can define variables, right? So it's supporting defining variables and stuff like that. So let's try the newer one. Let's try the newer one. I'm gonna do git compile git clean fdx. Right, so I'm gonna clean all of that stuff in here. So here is the fork. Oh, it even has a develop and master. Which one? Like, I hate when people do that. So develop and master, what's the difference between them? So can I take a look at the develop? Is develop even used? Well, I mean, it is merged into the original fork in here. Okay, so let's actually do master fork, right? So this is going to be master fork. Okay, that's very cool. And now, so let's try to build the fork one, right? So this is going to be second one. I'm going to actually provide both of these things in the description. So here I provided the fork, right? So this is the fork, and this one is the original, like this. But I mean, the fork has a link to the original, right? So the fork has a link to the original. Anyways, let's try to rebuild the whole thing. That's a lot of warnings, my friends. That's a huge amount of warnings. Like, what the fuck? Can you just go ahead and fucking fix them? Or disable if they're nonsensical? Like, what the fuck am I even looking at? So multi-line comment. Okay, so you are using GNU 11, I suppose GNU with extension, but also being a pedantic about it. So yeah, that's a bit bizarre. That's a bit bizarre. But anyways, so we got this thing. So I'm gonna take a look at picoc. Okay, this one got more flags. So it got a copyright info and this help message, which is kind of cool. So copyright info is rather important. All right, so let's take a look at the interactive thing in here, thingy-majingy. So can it do 1 + 1? Still cannot do shit. All right, so can it do printf hello world? Right, so they added like extra 200 commits, I think, right? So because the original one has 500 and this one is almost has 700, so they almost added 200 commits. So I hope they fixed some of the problems that we encountered in here. Okay, so we can do printf. So can it support these kind of cases? So let's actually find out. Okay. So this is going to be printf, and I just want to see if we can do this kind of thing. And I'm going to close that, and none of that fucking works. Okay, so some people in the chat were suggesting to try to use something like this, right? So without the blocks or anything like that. So it's going to be ++i. Then I'm going to do hello world, right? So this is going to be hello world, a new line, and yeah. Wait, I is already defined. So okay, so does that mean I don't have to do that? Oh, so was it also saying already defined? I'm actually utterly confused. Like, what the fuck is going on? Oh my god, this is... So far, I can conclude that this language is not usable in interactive mode. Used in flight control something, by the way, yeah. It is not usable from REPL at all. Like, what the fuck am I even looking at? It's just like, this is not how I expect a scripting language to work. Anyways, but maybe you're not supposed to use it like that, right? So maybe you're supposed to use it from a file, right? So let's actually do hello C. And in here, I'm gonna just do print hello world, right? So I'm gonna print hello world. So can I do hello C? So are you telling me that do I have to maybe include stdio? It's just like, what am I even looking at? What is this? What is this even, bro? Okay, so let me see. You can't just provide a bunch, like, to run a script you need to So run a program calls. Okay, so there's two modes. Okay. Listen. There's two modes. This is a scripting mode, right? So this is a script. Okay, and in a scripting mode, it just does that. But then you can run a program and run a script. I mean, isn't script a program? So script, I mean, kind of based. It's kind of based that they don't consider a script a program. So it's like one of these text editors that separate scripting languages and programming languages. So it's one of those applications. Yeah. So there is, like, I think it's Guinea, right, or something. Fuck, I don't have Guinea, but I mean, or Genie. But I suppose I can install it. So xbps install. So Genie. I'm gonna show you. So do you guys know what I'm talking about? I think I already showed that on the stream, but it's kind of hilarious in my opinion. It's kind of hilarious. Is that in Guinea? So there is file types. I don't quite remember. I think it's somewhere here. Set file type. Oh fuck! Did they change that? All right. I feel like they changed that. But in the older versions of Guinea, right? So they had like in the file types, they had two categories. And one category was programming languages and another one was scripting languages, right? And programming languages had things like C, C++, Java, and so on and so forth. And scripting languages were JavaScript, Python, and so on and so forth, right? So they kind of imply that Python and JavaScript are not programming languages, they're scripting languages. So it's kind of a similar situation in here, right? So this is not a program, this is a script. I suppose, yeah, so let's actually try to do the following thing. So can I do main, right? So can I put main in here and also return a 0? Is that something I can do? And then run it without the script. Okay, printf identifier still not found, by the way. Right, so I probably have to do something like this. Okay. That is very interesting. Right, so, and it honestly, it does look, it is fully compatible with the C language, right? I wonder if I can do shit like that. All right, so, and on top of that, can I iterate? So does it even support size t? It's actually a very interesting question. So let's actually not do size t because argc is integer anyway. So can I do stuff like this where I would just do something like that? Argv I, all right. So what about full bar buzz? Cannot read file. Okay, so maybe I can put dash in here. How can I pass arguments in here? How can I pass arguments? So let's take a look at that. You have to put a dash, a single dash, not a double dash. Look at that, and it even, that's kind of funny that, honestly, I would expect that the program name, right? So usually argv0 is the program name, isn't it? It is a program name. So in this specific case, I would expect the program name to be hello.c, just like in Python. Do you guys know how in Python it is? Like, I don't remember. I think it's OS, and in OS you have like args or argv. Where is it? Does anybody remember? Was it OS or system? Oh, sys, yes. So the sys, I probably also have to import sys args, argv, or whatever. Yeah. So, and in Python, I mean, I compared it with Python a lot because they claim themselves that this is a scripting language. If you call yourself a toy scripting language, you're going to be compared with Python. Okay, I think that's fair, right? I think that's fair. So I'm going to do sys, and here is going to be sys argv. Right, so and then here Python 3, and it's just like, yeah, that makes sense, right? So the first thing is that, so I can do full bar buzz, and yeah, so it's kind of funny. It's kind of funny, but anyways, does it have dynamic array? That's a good question, actually. Another question that I have is, does it have macros, right? So it does support include syntax, but it doesn't mean that it supports preprocessor macros. It might be supporting that small subset of the C syntax, right? So can I do something like a foo and just like do something like a boba. Will it replace it in here? So I'm going to put s in here, and I'm going to just put foo. Since it's a boba, let's also call this a boba as well. I think that's fair. I think that's fair. Okay, so let's actually try to call this thing a boom. It got replaced. It got replaced. Okay, so how well does it support the you know, the preprocessor macros? Can I put x in here? Right, so, and then I can say, return me this thing as a string. So, and then I can put 69 in here. So does that support this thing? Okay, okay, it doesn't support that. It's not really that powerful. It's not really that compatible with C preprocessor. So variable ident x is identified. Okay, so what if we don't say that it has to be stringified? Because stringifying is a very advanced syntax of a C preprocessor, right? Let's actually cut it some slack, right? So let's assume that it doesn't support that because it's too advanced for such a toy scripting language. It's too advanced. All right, so if I try to do something like this, okay, so it returned xxx. Why did it return xxx? So there is a little bit of an incompatibility with the type. I do understand that. But why did it say xx? Yeah, I know that it's s, but is that how it reacts to that? Is that how it reacts to that? It's just like it's when the types are incompatible, it just says xxxx? Because it's a 69, so it got censored. So that's what man. This is such a disaster. It's so fucking entertaining. Holy shit, I really like that. Bro, I'm giving it a star just because how entertaining this entire thing is. It's an absolute fucking dumpster fire. Like, I'm never using that in any of the projects, but man, is it entertaining to just look through this thing. Alright, let's keep going. So what if I provide like a D in here? Right, so yeah, so it is a 69, but if I put S in here, so it's xxx. I'm really curious. So what if I grep xxx in the code base? Okay, source string. All right, so there's quite a few xxx's. So xxx, a possible bug of L. So I suppose it's sort of like a to-do of some sort. Right, so, all right, so this cstdlib, all right, so std outputs xxx, ooh, wait a freaking second. So this is a cstdlib, Is this thing literally interpreted? Wait, just a second. So this is implementation, but is it compiled into the interpreter or is it interpreted by the interpreter? Because you can literally maybe like at runtime feed that into the interpreter and it will just interpret this thing and do some things. I don't freaking know. So this is std. So, but I don't really see just a regular printf. Okay, so there's a std. It's probably not. So we can just look where this thing is used. So I'm gonna literally grab stdio.c. How is it even used? All right, so in a make file, it is just, yeah, so it seems to be just compiled, right? So it's just compiled. So this is the file itself. And this is the interpreter. I'm not quite sure. I'm actually not quite sure. If it's a potato, Windows user will crash when you include... Yeah, that is true, actually. That's a good point. So it's probably baked into the interpreter, right? So it's probably baked into the interpreter. And xxx, I'm not really sure what xxx is supposed to mean. Yeah. So, and I suppose if show type is long type, and this argument is a numeric arrays, you print that, otherwise, yeah, so this is literally incompatible type, right? So if something is not convertible or whatever, the amount of arguments does not match. So there's a long type, unsigned long, and for example, So we had a string type. Does it have a string type in here? But anyway, so, and I wonder, so they use XXX actually also as a to-do of some sort, right? So as a to-do, and I wonder if they put XXX in here to sort of like tell, just, you know, come up with a good error message later. So I used to mark problems and to-dos with XXX and exactly. So it's a common thing in here. Look at that, and they also do that. So it's just sort of like yeah, it's a to-do, and it's a to-do that got never fixed, right? So basically, just come up with a good error message in here. Maybe just print out something to show an error without crashing program. Yeah. There's something like that. Right, it's kind of funny. But anyways, so here's that, and where's my hello.c? Okay, so that's kind of interesting. It partially supports this thing, the preprocessor, right? So, but it doesn't allow you to stringify things. But do we even need stringify? I'm not quite sure. Anyways, can I define structures, right? So if I want to have a structure and I want to have numbers, is that something I can do? Especially if I define numbers somewhere here. So this is going to be x's, and it's going to be something like that. Okay, so let's try to maybe execute picoc hello c. Oh. Bad type declaration. Bad type declaration. Okay. So is that because it just doesn't have anything? So let's actually define a bunch of items in here, and then maybe size t count, and then capacity, right? So let's try to create a dynamic array. Let's try to create a dynamic array. So we'll be able to succeed there. Okay, it doesn't know about size t. But I mean, maybe we can try to include stdlib, because usually it's defined in stdlib. It doesn't have size t. Doesn't have size t. It doesn't have size t. So it's not that compatible with the, you know, with the original C. So we have to maybe just use integers in here. Okay, can assign structs. Is that a memory corruption of some sort? stddef? We can try to do stddef. Right, stddef. Okay, so, and there's no such thing. But can anybody tell me, what the fuck is this? So it feels like cannot assign struct from, like, it feels like it's trying to print the name of the array, but it just couldn't, and it corrupted the memory. Struct 001. Yeah. If I try to grep this entire thing, can I find that? Okay, what if I try to grep this? Well, I mean, it got interpreted as the regular expression. Okay. TMP name buff. So it is related to like some structures in here. Parse struct or union, and it's a temporary. Okay. Very good error message. Thank you very much. But anyways, so can I just allocate it on the stack? Is that something I can do? So can I at least allocate it on the stack? All right. So abobo isn't defined. Okay, so let's actually remove all that stuff. Okay. We managed to define a dynamic array structure, and we managed to allocate it on a stack of the main function. So it feels like a standard project I wrote 5 years ago, and everywhere errors, hee. Well, I mean, yeah, it was written 10 years ago, essentially. Anyways, so what we need to do in here, all right, so we need to maybe append a bunch of things in here, right? So can it malloc? We're bound to find out. We're about to find out. So I want to append like 10 things in here, right? Might as well maybe append starting from 10 to 20, right? So that's the things I want to append in here. So how are we going to be appending this entire stuff? So the real question here, by the way, is it properly initialized? Right, so if I try to print, for example, items, it's going to be a pointer, by the way, so it's going to be access. Because maybe it's not zero initialized even, right? So maybe we allocated it on a stack, it could be just a garbage. You never know. Like, and usually things that are allocated on the stack, they're usually filled in with garbage. You guys know that? You guys know that? So, right, so we can take a look at the count and we can take a look at the capacity, right? So if I do something like that and I'm going to do pisos, yeah, so this one has to be an integer, right? So yeah, there we go. There's 0 initialized. So we can actually try to compile this with a real C compiler. So we can try to do GCC, so it's going to be hello. And that's a kind of a cool advantage of this project, even like, you know, ignoring all of its downsides, obvious downsides. That's kind of cool thing is that you can have like a universal code, which is both native code and a scripting code. That's kind of cool, I think. And usually, as you can see in GCC, this is a garbage structure, right? Quite often, and I don't think it's specified by the standard, but maybe it's specified, I don't know. Right, quite often if you just allocate a thing on the stack like that, it's going to be filled in with garbage, with a random garbage that happens to be on the stack. And as you can see, it's different. You can use it as a random number generator if you want to, but don't depend on that behavior. So usually to actually prevent from doing that, just ask the compiler to 0 initialize it. But if you don't 0 initialize it, yeah. So it's something like that. But from what I can see, picoc 0 initialize everything, right? So, but I don't know if it's specified or not. But anyways, so get that. So what we want to do in here, we want to just like push something onto that array. So if we had enough capacity, so the way we would have pushed it is something like this, right? That's the easiest ways to push it, right? So maybe you might as well just rename it to X to make it consistent with the name of the dynamic array that we're pushing it in. But that may not work if the count is greater or equal than the capacity. If something like that happened, we have to stretch. We have to stretch our dynamic array a little bit. So how we're going to be doing all of that stuff? We can basically take the capacity and multiply it by 2, right? So that's the usual strategy of growing, of stretching your dynamic array, right? Just like multiply it by 2. So, and after that, what we're doing, we're just reallocating this entire thing, right? So access items, and that's going to be access capacity, and we're just reassigning this whole thing to the items, right? So that's pretty straightforward. What's interesting is that this is not going to work if your initial capacity is 0, because if you multiply 0 by 2, you're going to get 0. Dynamic array guy is doing this again. Anyways, so yeah, so we probably have to check for the case when the capacity is equal to 0. If it is equal to 0, let's actually maybe put it to some predefined value, 256 or something, right? So and let's put else in here. Okay, so that seems to be good. It's a pretty complicated code, but can picoc handle this code? Place your bets, chat. What do you guys think? Will it succeed or will it not? So we're about to find out. It just took it like a champ. It just fucking took it. Like we don't have any side effects or anything, but it's just took the thing. So yeah, we can try to print the current state of the structure, right? So what happens if you don't realloc? Well, it's just over. That's a very interesting question. So yeah, this is a very interesting question because C is an unsafe language where you can poke around the memory however you want. Can picoc do the same? So can picoc put stuff in the wrong places in the memory? All right, so if I try to do something like that, oh my god, it literally will. It doesn't even have a virtualized. Oh my god. You can have buffer overruns. You can escape the interpreter. You guys do realize you can escape the interpreter. Holy shit, it's such a great C interpreter that it is as unsafe as C. It's a yeah, you can have a remote code execution with this shit. Simulation is too realistic, exactly. Oh boy, I love it. Captures C nature, yeah, it's a captures C nature pretty perfectly. Anyways, remote script execution. I like this. I like this interpreter. It's so bad. It's actually good. Like, it's one of these things. They're so bad. It's good. Holy fuck! I love this project. Anyways, I like the way it's exactly. So I want to take a look at what's the state of the structure, right? It would be kind of cool if I could print the structure, right? So does it have like a V like in Go? I'm pretty sure it doesn't, right? So you can't do shit like that. Yeah. Thank you so much. So let's actually like print them separately. So it's gonna be items. It's going to be items, this is going to be count, which is going to be D, and this one is going to be capacity. Alright, so, and again. Okay, so, and look at that. So the capacity is 256, this is the items that it allocated, and the count is 11, and I actually put equals in here, which does mean that it is 11 elements, right? So from 10 to 20, you have 11 elements. So, and the next thing we can try to do is to just iterate this dynamic array, right? So we're iterating this dynamic array, so access count plus I, like so, and let's just print the whole thing. Might as well print the index in here. So it's gonna be I and access items I. Access items I, and if I try to, yeah, so you can have dynamic array. That's a plus in my book, right? That's for sure. Like you can do this kind of stuff. That's very interesting. Wait a second. Does it have an assembly? Can you insert assembly in here in 3? Nah, it doesn't support that. It doesn't support inline assembly. What about this kind of thing? Nah, it doesn't support that. It would be too much, unfortunately. Yes, it would be too much. But yeah, you can have dynamic arrays. That's pretty bogus. So what else can you do in here? What else can you do in here? We can take a look at the examples in README. So you can do the usual stuff, right? That looks like a usual stuff. So here's the script, interactive mode, environment variables. In some cases, you may want to change the picoc stack space. Okay, so that's compiling picoc. Oh, it's just compiling the project itself. Adding native C functions. Picoc allows you to define your own library function. This function is written in C using your system's native C compile. Alright. But this is kind of lame! Brovsky! For real? So, and it's a... Why don't they use like libffi or something? Why don't they use like a libffi? Would be kind of cool. All right, so let's actually take a look at the their FFI ability. And isn't it kind of stupid that you have to, in a scripting language that is LARPing as C, you have to write wrappers to run a C code, and it doesn't run the C code naturally. Isn't it kind of meh, I would say? They actually see and they don't have FFI. Yeah, exactly. That's kind of lame. All right, so your picoc distribution contains 2 files which are used to define library functions for your system. If your system is called foobar, you will be using library foobar.c. This is where the foobar specific libraries functions go. C library C, this is where standard C functions like printf are defined. So we'll start by adding a simple function in library foobar. We need to do 2 things. Add the function prototype to your list of picoc library functions. Define the native function C implementations of the function. Alright, so you need to have 2 files, library foobar.c and C library. All right, so this is where foobar specific functions go. All right, so does it have DL? I have no idea. It's probably not, but I mean we can probably implement that. So each of the library X files define a list of picoc prototypes for each of the functions as defined. For example, like this. So this first column is the name of the C function, the second column is the function prototype. the null line at the end is required. Why? Can't you just know the size of it? Can you just figure it out the size of it? That's kind of weird, but anyway. So the native function, the native C function is called with these parameters. Yeah, this is like an umca FFI, right? So you have a return value, you have a parameter value. So the classic lazy scripting job. The classic lazy scripting job. Kind of cringe. I do agree with that. It's kind of cringe. I would expect a little bit more from this project, but it's, I mean, it's abandoned, so whatever. Right, this is a C native. Here's an example of function defined random. Yeah, and you just like do that. Passing arguments. Okay, cool. I've got these two files. How the fuck do I compile them? How the fuck do I use them? I don't quite get it. So passing point is like, okay, I get it. I get it. Maybe I just missed it. But I don't see how you then compile. So the picoc system contains two files which are used to define libraries for your system. If your system is called foobar system. So here is the... so do I have to recompile it myself to get... that is bizarre, honestly. Library. So there is a library.c and there's a library init. I don't quite understand what the fuck do you want. Okay, so it's a platform library. Maybe it does exist in here. Platform library. Oh, here it is. Well, I mean, it's in the README. Seems underdocumented. Yeah, I do agree with that. That's... oh, here it is. Here's the library. That's what it is. Okay. So here are the platforms: library MSVC, library Unix, platform SVC. Okay, and so that kind of makes sense. So, and we are in library Unix, I suppose. All right. So where is the? So there's a Unix function, library functions, but it's just... oh, there is a test function in here, and in a test function it just printfs. Can I do oh wait, what the fuck is going on? Do I have to reset? Okay, so picoc interactive test does okay, so test seem to be accepting. I guess that's what it is, right? So, and this function is defined in here, and that's how it works. All right, so I would like to take a look at maybe library definition and how it's defined and stuff like that. But first, let me actually find all of the files with the name CNH, right? So that's what I want to see. So this is a CNH. So the idea of, honestly, so I'm going to make a little bit of interruption. The idea of a scripting language that is mimicking C and compatible with C on a source code level is kind of a cool idea, honestly. It's kind of a cool idea. It's a interactive C compiler, you know, an interactive C compiler, and it would be also kind of cool if you could call it from within itself to like dynamically compile some of the code and execute it and stuff like that. But this execution of this idea is terrible, freaking terrible. So wasn't it a holy C idea? It's not compatible with the standard C. So the key here is a compatibility with the standard C. So you can basically maybe take the actual source code of Raylib and interpret it as well as compile and stuff like that. That's what I'm talking about. Holy C is not compatible with C. It's not even C. It's a really weird amalgamation of C and C++ syntax. For whatever freaking reason, Terry decided to, for example, call structures classes, but semantically still leave them structures. Can anybody explain to me what the fuck was happening in Terry's head? Right. divine intervention, right? So only God knows. Yeah. So this is like if you semantically leave them to be structures, why the fuck did you call them classes? And it doesn't even have member functions to justify the name of a class. It's not even a class in a OOP sense. You know what I'm saying? It's just like, what is this language? What is this language? It doesn't even have like a proper type checking, but I mean, I can rant about HoloC like the whole day. But anyways, so let me actually feed this entire thing into e tags. Right, so this is gonna be e tags. They also have a platform thing, which also might be containing some of the platform stuff, but I don't think they ever documented. Oh, okay, so porting picoc. So platform.h is where you select your platform type and specify include, etc. Contains support functions so the compiler can work on your platform. Okay. Contains your library of functions you want to make available to the user program. Right, there's the C, which contains user library functions like printf, which are platform independent. Okay, so I see what they were trying to do in here, but all of that is baked into the interpreter. You can't just load new libraries in the interpreter, unfortunately. Right, so you can't just load that stuff. So essentially what I want you to do, I want you to basically do something like this. So let's go into the tags. Here's the library function. And yeah, so this is just a function pointer, and the prototype is a literal string. What if I have a syntax error in the prototype of this thing? What if I have a syntax error? So what's going to happen? So does it try to parse this particular prototype as a C code, or maybe it basically injects those prototypes before actually interpreting the original source code, so they are kind of forward declared. So they become forward declared for this entire thing. But anyways, so I'm going to try to recompile the whole thing. All right, so yeah, so make JB. Everything compiled successfully, but I suspect if I try to execute this entire thing, it will. Yeah, so essentially you can have bogus amogus prototypes for your custom functions, and it will never be caught on compile time, or when you recompile the interpreter, and it will only be caught during interpretation, and you will get a horrendous error message that you will never know what the fuck all of that even means. So that's that's hilarious, honestly. That's hilarious, but I mean, okay, so what else can you do? What else can you do in here? Anyways, so let's try to do something like this. Yeah, so that seems to be working. So there's also a line number. What was that supposed to mean? Right, so it returns an integer, so that means maybe you can do some stuff in here like that. So line null. All right, so it's a line number. What if I call it? Oh, look at that. So it's just like it keeps incrementing. It keeps incrementing. Okay, cool. So this is a library and stuff like that. So let's actually put something like your mama, and it's gonna be void your mama, and it's gonna be something like that. Funny thing. Oh yeah, so it's not gonna compile, so I'll have to implement this thing. So where is it implemented? So it is implemented somewhere here. So it's right there. Okay. Okay, so your mama, and we don't have a return value in here. So this is how you return something. Though this is very intuitive, right? So it's basically like a umka FFI, right? So it's basically like a umka FFI. So, and this is a see your mama, and your mama is here. All right. Let's try to compile the whole thing. I'm really annoyed by these warnings, but I mean, what can I do? So, your mama, boom, your mama is here. Oops. That's how FFI works. So the way this interpreter allows you to do FFI, you modify the source code of the interpreter and you recompile the interpreter. That's how you do FFI. Fascinating. Fascinating. So let's do Raylib, I suppose. I don't fucking know, man. So what we can do, we need to just maybe copy paste this whole thing in here. So C Raylib init window, right? So this is gonna be something like that, and I'm really fucking annoyed that you need this null because it indicates the end of the array. Okay, so let me educate you. Okay, so where's the errors? So undeclared in here. Okay. Include a register. So you just take a pointer to this first thing. And here is the function list. Okay, so here is your function list. And this is a new library. All right, and in this new library, you have a func list. All right. So where's the errors? So func list, okay, so that's understandable. This is a func list. Yeah. Look at that. So while func list not equal to null, so what they essentially do, they increment this func list, right? So do I understand this correctly? They just increment this func list. So this is going to be that. Yeah, library add. But I'm not quite sure, right? So in here, how do they increment it even? I didn't see the increment though. All right, so if I put it like that, where is the increment happening? Yeah, I don't quite see it. Did I miss it somewhere? But essentially, you can always just get the size of the array, right? So you already have enough information to get its size, because this is like a fixed array, right? So you do just this classical trick. So essentially, if you do size of Unix functions, it will give you the size of this entire array in bytes. So then you have to divide it by the size of one first element also in bytes, and you literally get the amount of elements in here. And that it makes the code less error prone because you can very easily forget to add this null in here. Right. So, and it's like this is basically a standard way of doing that, and I don't know why they didn't do that. So array size macro, yeah, so this is a classical array size macro, and I don't understand why they didn't do that. So, and I couldn't find where they organize a loop, but I mean, I found where they check, right? So this is where they check whether this thing is not equal to this thing. All right, so set up a library functions. So this is maybe this is where, because yeah, if we look a little bit deeper, in the errors. So, and then, so this is that. Yeah, so here it is. That's basically the loop. So, because you have to set two of these things to null. So here, which they check in for the null, and this is how they know that they reach the end of this thing. Bro. Just pass additional fucking size of the function list. Freaking pass the function like size. Right, and compute the size with the array size macro. I don't know why this annoys me so much. I know why, because it's so error prone. This is literally the reason why C gets a bad rep. Because you're not doing it right. Like, what the fuck is this shit? You're making a code like very error prone. Don't do that, please. They just copied from CPython. CPython does this kind of thing, right? So is that how CPython does it? I don't freaking know. Anyways, so let's continue. So we have a bunch of errors. I probably have to continue with these things. So errors underscore. Yeah. Do I want to just? Yeah, let's do the following thing. I'm going to replace func list underscore with just func list and be done with it. All right. So everything's fine. So what I was working on, so just like a little bit of a rant, Get opt does it too, if I recall correctly. Well, maybe it's all like an old thing, right? So people, maybe it's an old-fashioned way of doing it. A lot of people just did that for all sorts of libraries, and now we're kind of stuck doing that if we want to use these libraries, like in case of get opts. Right. So there another thing, for example, is exec ev or exec vp. I don't remember. So the exec family of the functions, they accept the arguments. And if you take a look at their description, right, as you can see, they never specify the size of the argument. So except the file of the program that you need to execute and the arguments which you want to execute them with, but they don't specify the size, like how many arguments. And this is because you're supposed to put a null at the end of it. And it's very easy to forget. Yeah, so execvp expects a null-terminated one. And there's nothing pretty much you can do about it because execvp is like a syscall, essentially. So a lot of these functions are wrappers around the syscall, but as far as I know, the syscall also expects you to null-terminate it. So Amiga and 3D style arguments stack arrays similar. Yeah, so it's kind of like an old-fashioned way of passing sized arrays or sized strings and stuff like that. It comes from the same sort of like a style which introduced null-terminated strings, I suppose. Makes sense. Makes sense, I suppose. Let's continue with the Raylib speedrun. So, yeah, what we need to do in here is init window. All right, so init window. For now, we can just basically hardcode init window. Right, so I'm gonna do init window, picoc window. It's gonna be 800 by 600. So I'm gonna leave it like this, and I want to actually put this thing like that. Right, so this is the thing I want to put in here. Right, and if I try to compile the whole thing, it's obviously not going to work. Right, it's obviously because you don't have a init window in here, like you just don't. I suppose one way you can fix that is by including Raylib, right? And it's also not going to compile because you don't have a Raylib nearby, right? It can't find that. So what that means is that you have to modify the build thing. So far, by the way, after an hour of using this language, I have concluded that this language is not particularly production ready, at least for what I would envision it to use it, right? So I personally wouldn't use it for anything. What about you guys? What do you guys think? Is this language usable for anything? It's kind of like a panim. Maybe for panim, actually. It's kind of interesting. It's a toys language. Yeah, it is a toy language. Maybe 10 years ago when it was created in an environment where it all kind of makes sense, but today maybe it doesn't really make that much sense. I don't think so. But anyway, so here's the cflags right in the makefile, so we can modify that. Oh, this is a kind of cool way to embed like git hashes. It's kind of a cool way to embed git hashes. Nob scripts. Okay, so let me put I in here, and at home, maybe somewhere here, I have opt. Do I have Raylibs? All right, here it is. Where is the Raylib? Like this, and it's going to be include. So will that work? Okay, so still complains. Init window passing. Is that because I fucked up the order of the arguments? Okay, picoc window. All right. Okay, so now we're failing with the linker error. All right, so that should be relatively straightforward. So in the linker, we can put lib, and we can just put L in here, and this is going to be lib_raylib.a, and there we go, it seems to be compiling. And if I do something like that, init window, boom. You can basically have, this is kind of funny. So you can have an interpreter which is literally Raylib interpreter. It's like a, and it's, you can probably even execute some of the Raylib examples. You know what I'm saying? So you can probably execute some of the Raylib examples, right? That's kind of funny, actually. Raylib without modifications. Can you do that? Not quite sure. because some of them, they include Raylib, right? They include Raylib. So is there an example? So here's the core. Okay, so it's a basic window, and yeah. So what's the name of the file in here? We can copy paste this entire thing. So Raylib basic window.c. I'm gonna put it in here. So one thing it does, it includes Raylib, but I feel like theoretically, if you provide bindings for all of these functions, this example will just work without modifications. Straight second example link. So core basic window. Okay. Raylib core basic window. So as of right now, if I try to execute picoc and just core basic window, can it read? Yeah, that's kind of interesting. So you can include stdio and stuff like that. So that's what's funny, right? So if I try to grep can't read, so what is it going to say? What is it going to say? All right, so can't read. Fuck me, mate. There's a lot of places where they're saying the same shit over and over again. Okay, so platform read file. This is a platform read file. This is a platform read file, and this is a platform. Yeah, so this is just a single platform read file. So I suppose include just calls platform read file. It just calls a platform read file, and in here, where do we call that? So here is that platform scan file. Oh, okay. So source ignore. It's you can shebang this wait a fucking second. You can shebang Pico. Did you guys know that? Well, I mean, it has to be located in some place, so I'll have to copy paste it somewhere. I'm not really sure if I want to do that, but I can do that. Maybe picoc. Okay, so pwd. I have, here is my root in here, right? So here is my root. I can literally just go here, right, and copy picoc to user local bin, super quick, right? So it's now in my root. If I take a look at which picoc, here it is. I can literally just use that. So where's my hello.c, right? So, and I can probably put this thing in here. A shebang. And then, so I can maybe make this thing executable, right? So, and if I do hello.c, it works, right? So I can shebang c. Okay, that's pretty cool. So you can shebang the whole thing, and I wonder, is it still compilable with the C compiler? It feels like it won't be compilable with the C compiler. Yeah. Invited. Why C compilers just don't support shebang like that? Why don't they just support shebang? I think not even support it, but just ignore it, for instance. TCC also. Yeah, I remember that actually. I actually remember that. It's Big Bang. All right. So this is the basically platform scan, and you just do picoc parse, and yeah. So I just want to find where you process the includes. Where do you process includes and stuff like that? Okay, so probably from here. Oh, there is literally include.c file in the interpreter, which is probably responsible for include file. But it's already like called by somebody. Let's actually go up the call stack. Where do you call this entire thing? Okay. So this is straight up tokenization. Right, so this is a parse statement. I have a little bit of a flashbang. Yeah, that's what it's called, flashback. So include file, right? So include file, and do you just include any file? Does it handle them somehow? Can we? So file name. So it compares. So there is a include files in. So in the state of the interpreter, this is, I suppose, the state of the interpreter, you have include lib list, and you have include library, which is a name, and you have a setup function. You have a setup function. And if it's one of those things, you just do that. Which brings me to a very interesting conclusion that maybe we have to add that include library somewhere. So here's include liblist. Where do we assign it? A list of libraries we can include. All right, let's take a look at that. So let's actually try to recompile this entire thing, because I want to make the Raylib example compilable without modifying the example. Right, so what do we have in here? Lib include, all right, so yeah, that's understandable. What the other thing? Cleanup, this is just a cleanup, that's understandable. New lib include, okay. So there's a setup function, include register a new built-in include files. Okay, so this one is going to be include list. I'm going to put underscore in here. Error, and yeah, like this. So so I probably don't need this kind of thing anymore. But I already have to, yeah, I'll have to commit that and rename all of these fields in here, which is kind of annoying. Okay, so here it's trying to, there we go. And look at that. This is rather interesting. Is that because it is not exposed to the platform stuff, right? So because we had like a platform in here, and I didn't think platforms are allowed to register new includes, are they? So include, they are. Okay, so you can just like, okay, that makes sense. You can just register some of these things in here. So in Unix setup functions. So essentially what you do with this thing is, it, instead of including this thing, it will call some of the functions. You know what I'm saying? It will just call some of the functions. Can I nuke some of the stuff in here? So include register, or include.c, include register. So I'm gonna like remove it back. Hopefully it will compile now. Okay, so that seemed to be compiled. So setup function, and in here, where is the Unix setup function? It doesn't really do anything. You know what I'm thinking? Can I just add raylib.h? So it's a Unix. So oh, блять. Can I literally have library function, Raylib functions, like so. Don't forget null at the end, and move all of the Raylib shit in here, and essentially say, okay, when you include that, include Raylib functions. All right, and I also need to have like a Raylib setup functions, but I don't think I'll have anything in there, so it's going to be an empty function. This is kind of cool, isn't it? Raylib setup func. So essentially we're separating them into like namespaces, if that makes any sense. But since it's a like user function, it has to be yeah, it has to be in this library thing, but I put it already in the platform, so it doesn't really matter. Well, I mean, it's in library Unix, so I think we're in the right place in here. Let's try to compile this entire thing. So it failed. Let me take a look at what exactly they. Forgot the semicolon. forgot a semicolon, spent 3 hours debugging. So if I try to open this thing now in interpreter mode, right, and if I do init window, I'm pretty sure still worked. It still worked. It's kind of interesting, but I should be also able to include raylib.h. And can I include test.h? I cannot, right? But now I'm able to include raylib.h because I registered this thing, you know, in the platform thingy. So next step is using STB selector to generate this table. That's not a bad idea, honestly. I feel like it's not a bad idea, but anyways. All right, so let me try to call this thing one more time. Do we have a picoc? Yeah, so core basic window. Yeah. Type not expected here. Where is it expected then, you mother flipper? Wait, are you telling me that it doesn't support consts? Is that what you're trying to tell me? You don't support const variables. It doesn't support const variables. We literally can't do that. Okay, I want to make this example work without a single modification. Define, well, this is modification though. This is modification, so I'm not a particularly huge fan of this shit. Can we just add support for this stuff? Can we just add support for them? How difficult would it be? All right, so there's a core window, and so here's the lexem. What kind of lexems do you have? Do you have a lexem which is like an integer? It literally has a lexem for an integer, for instance, which makes me think. So where do you use that lexem? So here is the type. So type parse front. Okay. So parse a type, just the basic type. So, and then you have a token int type. All right, so do we have const? Yeah, literally there was no const. Okay. Let's add const. Yeah, that's kind of weird. What the fuck? What the fuck? When optimizations are set, escaping certain characters is required or they disappear. What? When optimizations are set, escaping certain characters is required or they disappear. Well, they disappear, okay. It has auto, by the way, right? So, but it doesn't have const. So if I just add them, so let's actually add them. So they're sorted in alphabetical order. So that means maybe const goes here. Yeah. Yeah, it goes somewhere here. Token const. Yeah. And it's not going to compile, obviously, because you probably need to define it somewhere. Let's actually do something like that. So, so, yeah, token const is not defined. Where this shit is defined? Okay, interpreter, and here are the lexems. That's pretty progress. Why are they numbered like that? Couldn't you just make them equal? Like, did you know that you could have just said 0, 0? It feels like these specific numbers could be very much important. So I don't want to insert anything new in the middle. New and delete, they have new? They have C++ keywords, though they don't have a const, which is a C keyword. Yeah, Holy See situation. By the way, it does feel like a Holy See situation. Okay. Can I just do token const in here? Is that something I can do? Some decisions were made, yeah. It seems to be working. Seems to be even, I would say, it's working. Anyways, so where did we have all of that, Scheisse? So it was something maybe interpreter. I forgot where all of that was. We'll have to grab that again. Token int type. Yeah, we'll have to grab that Scheisse again. Boom. So this is a parsing, and this is a parse statement. Oh, this one is interesting. So, parse declaration, and parse and declaration declare a variable or function. This is probably where we want to do that, honestly. That's probably where we want to do that. The way I want to do that actually is case token const. If you encounter const, essentially, can I skip the token? XXX. How do you skip the token? How do you skip the token? Where is the skip function, mate? Lex get token. So take a note of where we are and then grab a token to see what statements we have. So you just grab it, but what if I want to say next token? So here is the get token. Get the next token given a parser step preprocessing as we go. So maybe this is just can I token const and then just fall through? Probably not. Anyway, so who's looking down? Int x 69. Okay, const int y 69. Interesting. Lex.c. Let me see. So we found a nail in our hammer. Yeah. 852. So what is this function even? Get row token. That's bizarre. What the fuck is this assertion even? Excuse me. Of all things. It makes me think that this was supposed to be like a last one, and then people added more things in here. I'm utterly confused. Why does it have to be? I reckon this code having some magic going on. Yeah. Why do you assert that? Your new token is after end of function. That is true, but that's not the most bizarre part. It already had something after end of the function. What's so special about this value? It already had something after it. Was it also added but then never kind of checked? What is going on? Backslashes for the line continuation. But I'm really afraid to put const in here. You know what I'm saying? But maybe I should give it a try. Let's give it a try. Okay, that seems to be compiling, right? So, and const int x69. Bad type declaration. That didn't work. All right, so yeah, that was bizarre. So type const. So the only thing you need to do, right, when you encounter this kind of thing is, well, I mean, we had two places, right? So grep bad type declaration. Bad type declaration. There's quite a few places in here. And if I take a look at that, parse front, parse a type, just the basic type. But why is it called parse front? Type parse front. Okay. Is that because of the it's split into? But anyway. So get token. I can put this thing in here. So token backslash is a special case indexed to n macro lex.c. Okay, so again case token const and go to again. This is very hackish, but maybe it will work. I'll see. Int x69. Absolute majority man. Sorry. We extended the language. Yeah, we extended the language. So now we just ignore. Right. So the only thing we need is just support for the syntax. So it doesn't really need to check for whether it's actually constant or not actually constant. Who cares? Just support for the syntax. Make a pull request. I don't think they will answer to my pull request. I just have a suspicion that this project is kind of dead. I don't know. Make a fork. Honestly, if I were to make a language like that, like I would just create something like this from scratch with my own vision. So because I honestly don't like the way it is implemented, right? So I don't know. But anyways, so it's better to create something like that from scratch. Okay, so let's try to run the example, the Raylib example, and okay, finally it fails at init window because too many arguments for init window. We just need to add support for all that stuff. Okay, very cool, very freaking cool, my friend, very cool, very cool, very cool. So let's go into the Raylib init window. So I'm gonna literally grab this entire thing like so. And now we can try to recompile the whole thing. So can I just recompile it like this and just try to run the whole thing? Okay, so as you can see, it even started a window, right? So it couldn't do set target FPS. And furthermore, by the way, we had coded some of the values in here, so we should not do that probably. Okay, so here's the test, and it accepts the parameter. Oh, you know what's cool? Is that I don't have to check the amount of parameters because they are already checked by the interpreter for me, right? Because it knows the signature. That is cool. So it's kind of almost statically typed, right? You know what I'm talking about? So essentially, I know for sure that it has 3 arguments because otherwise the interpreter would have not even called my wrapper function. Right, so that means I can just like directly access like 0, 1, and so on and so forth. Okay, so so the way I access these things is like this. All right, so that one, this is the first argument. This is the second argument, And then I have to provide the title, and it has to be the third one. It has to be, oh, by the way, does it also support const in here because we edit const now? I just didn't realize it, just like, it just worked, I think. What happens if you run picoc in itself? Nothing interesting, right? It will try to partially interpret some of the things, but I mean, it also spans over several files. So it's not that interesting, to be fair. So it's ignored anyway. Like, I'm surprised why they didn't just add that, because const is actually a very common keyword in C. By the way, that's a good point, by the way. You can have const int x69. So this is a valid. This is totally valid. Like, given how we implemented that, that's just totally valid. It's a very constant. Int const, like, this thing probably won't work. This probably won't work because we are ignoring const only in front of types when you're about to parse a type, right? So we're ignoring const. I think that's how it goes. Or maybe not. Wait a second. If I do const printf hello, it's sec false. So, which is weird, but I mean, okay. I fucking know why. Who knows why it's sec false? Who can tell me why it's sec false? Without looking at the source code or anything. 2 words. 3 words. Non-exhaustive switch cases. We edit a new enumeration, right? So, and usually how enumerations are used, you switch case upon them, right? So when you add a new kind of enumeration, that means you expose all of your existing switch cases upon tokens to a bug where it encounters that switch case, but it just cannot do anything. Right, so, and it falls through, or, yeah, so it goes haywire. We're gonna ignore that case, right? So we're gonna literally ignore that case, doesn't matter. But at least I now know, like, what to expect in here. Okay, so here, this one is supposed to be string. I don't know if string even exists in here. I'm gonna literally just, you know, guess it. And it probably doesn't. It probably doesn't exist. Okay, so there's no such thing as string. What do you have in here? And what do you have in here? So identifier. So what the fuck is identifier? Unsafe native pointers. So character. We can just try to do the pointer then, man. But one way we can check it out is by maybe literally printing it. So let's take it as a string, and I'm gonna grab this value and just interpret it as a string pointer. All right, let's go. Yep, that's how you do that. So you have to take a pointer. So this is a valid pointer in here. All right, so nice to know. Nice to know. So it failed add set target FPS. Let's implement set target FPS. Set target FPS. Set target FPS is just an integer of one single argument, like so. And in here, so set target FPS raylib.h set target target FPS. So that's the signature. That's the signature we have in here. Cool. Let's go. Window should close. This one is interesting. This one is interesting. Detect window. All right. And so let's go ahead and do it like this. Window should close. And this is a return type. Look at that. Return value. So the way you return a value is like this. So we can assign window should close, and in Raylib window should close returns a boolean. Let's assume it returns an integer because I suspect picoc does not support booleans. I suspect it doesn't. Window should close. This one doesn't accept. I wonder if it supports void. It probably doesn't. But anyways. All right. Begin drawing. That should be very straightforward. Okay. Begin drawing. We can even probably add the rest of the things. Core. So begin drawing and drawing and close the window. At least those things. And drawing and close the window. Those things. And those are relatively easy to add. Alright, so this one is going to be begin drawing. But it doesn't really accept anything and doesn't return anything. So that means it's just this. And I can copy paste this 2 times. Right, and the first one is going to be end drawing. And the third one is going to be close window. It's very straightforward things. Alright, so it complains about clear background. This one is going to be interesting because... Oof. So, yeah. Clear background. Clear background is a little bit annoying because it accepts the structure. So here's the signature, right? So that's your signature of clear background. And it's the last function that we probably need to implement in here, right? No, not the last one. It also accepts the text and yeah. This one is going to be rather interesting, I think. It's going to be rather interesting. So let's just try to implement that. So close window, clear background, and I'm going to just abort it. Maybe I'm going to assert to do. So when it fails, it prints the location where it fails. Right, so it's going to be rather convenient. Okay, doesn't know caller, right? There is no such structures. There's no such structures. And what's funny is that even if I'm passing a structure by a value, can I pass the pointer to the structure to Raylib? Is it even safe to pass that thing there? So there's a lot of questions that I have in here. And furthermore, if I want to define a structure, I can define a library functions, right? So that's one thing I can do. But how can I define a structure? So there's the include register. Okay. It accepts the setup function. So does it call a setup function first? Okay, so interestingly, yeah, so there's this setup function. I'm curious how people use these setup functions, because I have a suspicion that maybe in these setup functions they sort of feed the interpreter strings that define additional types and whatnot. This is the suspicion I have, how people use that. So I want to grab how people use include register, because it could be the case actually in here. Right, so here's a bunch of things, right? Include std ctype function. There is no setup in here, but std error no setup function. So variable, okay. So you can literally define platform variable. Okay, that's kind of cool. Can I define a platform structure? So define platform. Okay. So that's kind of cool, but I mean, define is probably, I can only define a variables, which is kind of lame. Math function, let's take a look at the, yeah, so it's just a definition, and these are probably like a defs, or like, you know, bound defined things. So they're not particularly useful, or, oh, it has a std boolean. Remember how I said that it probably doesn't support boolean? Right. It does support boolean. Define platform variable, setup function, table str register. type create a... Okay, so you can do things in here. So there is a thing type create opaque struct, but it's a opaque struct. Create a system struct which has no user visible members. Right, so type create. Do you have other type create? Okay, looks like it doesn't. So variable define. Would be kind of cool to just, you know, interpret a string, and that way you just like add a thing in there. So when I create an opaque struct, variable allocates. Okay, so type get matching. So given a parent type, get a matching derived type and make one if necessary. Identifier should be registered. What does that even mean? Parent type, is this OP? Parent types, what are we talking about? Excuse me. Parent type. I've got an idea, chat. Get an idea. So when two parent types get to... Okay, I see. Okay. I can actually do a little bit of a trickeroony. What if the clear background is not a color, but int? So, and then in the, it's a not Unix setup. I want to have like a Raylib setup function, and I set up, where is the core? So the rules are no modification of the original example, right? So no modification of the original example. So it stays the same, but now we define a variable with that name, and we literally put an integer value there. Right. So it's just like when you compile it natively, it operates on the structures, but when you do a picoc, it will use integers instead. Is that divine? I think this is a divine intellect, chat. I don't think it's too much voodoo. It's, yeah, so I think it's good enough. Right. So define platform var, but it's a FP type. Do we have other examples where it's not, you know, that annoying? Okay, so this is how you do the integer types. So here is the Unix, and I can define. Was it array white? Yeah, it was array white. Okay, and so e-access value. Oh, this is how you provide the value. You have to. Access value. So it has to be a global variable. You pass in a pointer to a global variable while casting it to... you punning it. I see. You're just punning it like that. It's a bizarre. Can you just like do void star then? If this is what you want to do, can you just do void star? Maybe not. Freaking no. But yeah, so it has to be global then? Is that what you're trying to tell me? That's probably what it's trying to tell me, that it has to be global variable somehow. But in our case, this is literally what is it? Honestly, you know what? We can do a pretty cool thing. If we had this allocated somewhere globally. I'm annoyed, chat. I'm annoyed. Does it have to be a global variable? Like, I'm really annoyed by the fact that it's global static variable. So what does it mean? Does it mean that it doesn't copy the pointer? Doesn't copy the value that this thing is pointed to? So it has to live for the entirety of the interpretation. This is stupid. Can this thing just make a copy of this pointer? Why does it have to be a fucking global variable? I want to double check that, like, what the fuck? So any value, so from value. Okay, it literally just stores the pointer to this thing, and it has to exist for the... Why would you implement it like that? This is... I literally have to have a static color ray white. Right, ray white. I can probably do something like this. Let's make a ray white color. But one cool thing I can do now is that I can take a pointer to a ray white color, right, and then reinterpret it as an... Maybe it makes sense on some other platforms, maybe, but it's... Nowadays I would say this is AI slope. It was 10 years ago, right, so... But anyways, okay, so what do we have in here? Ah, okay, so it didn't even compile because semicolon. All right. Aha, clear background was not implemented properly. Okay, so clear background. So we have to take the param something. What was the param 0 value integer, right? So this is a value integer, but we have to reinterpret it as a color. So we have to take a pointer, then cast it to the color pointer and dereference this pointer, like so. Let's fucking go, my friend, fucking go. Draw text. Okay, so now we need to implement this abomination. All right. Should be relatively straightforward, I think. So the only thing we have to change in here is that we have to accept integer in here instead. So this one has to be draw text, right? So this is a draw text, and this one is semicolon, and so on and so forth. Okay, so let's go like this. Draw text. Draw text. Ooh. Oh boy. Let me grab the signature one more time. It's gonna be fun. So what I have to do, this one, the first parameter is the text, so that means it's a pointer. It's a pointer, okay. So then the first one is a position, which is an integer, right? So this is an integer, another integer, font size, another integer, and color is another integer, but we'll have to reinterpret it as the actual color, like so. So that's roughly what we want to have in here. Okay, so it didn't compile as I wanted to compile because I should have done it like this. All right, so light gray is not implemented. So let's add this thing in here. So it's going to be light gray, light gray. And this is light gray color. Congrats, you created your first window. Absolute legend. And I can close it. So, and this is an example without any modifications, which means that I can compile the same example with a C compiler, right? So core basic window C, and I can do maybe so something like home opt raylib include. All right, so this is going to be really include. Can you see the whole thing? So it's rather elaborated, I think, but you need to see it. So and then we're gonna grab. All right, so let me maybe grab some of this stuff. I need to construct this thing core raylib. So core window, basic window. I forgot about it. Yeah. So let me grab this thing, and let me also grab this thing. We need to confirm, by the way, that all of that actually works the way I expect it to work. Sorry. Right. So So this is because we have to remove the home. You can't see shit right now, but that's fine. Okay, so and now I can do core window, and that's the native version, right? That's the native version. And then I can try to take the same source code, and feed it into our modified picoc, and it exhibits the same behavior, literally the same behavior. All right, so yeah, I spent almost 2 hours working on this entire thing, and I think I've got a pretty strong opinion about it. And I also made modifications. I extended the syntax, so I think I'm well equipped to talk about this particular thing. The idea is cool. The implementation is basically unfinished. Right, so the implementation is basically unfinished, and the implementation generally just feels like a regular toy scripting language. It doesn't have anything particularly interesting in it, right? So you still have to do this FFI ritual where you have to wrap each individual function and so on and so forth. They didn't try to use anything like libFFI or stuff like that to make it more convenient. So yeah. Overall, kind of an interesting thing to play with for one evening and move on. But the idea is cool. So also something happened 10 years ago or 8 years ago. It got forked, got continued development, and then it's just all got abandoned, and yeah. So, I mean, even say not intended to be a complete implementation of ISOC. That's understandable. But generally, the idea of a scripting language that is fully compatible with C is kind of an interesting one. It's kind of a cool one, I think. It's kind of a cool one. So, because it then makes the C programming language also like simultaneously compiled and interpreted, which enables very interesting use cases. I think Jai is kind of actually like developed in that direction, I think. Jai, in some sense, as we already discussed right on Jai streams, is simultaneously a compiled language and interpreted one, right? So during the compilation, it acts like a scripting language, and then it gets compiled to a native code and executed. So something like that for C would have been kind of interesting. Wouldn't be that hard adding eval to TCC. You do realize what eval for TCC means. Eval for TCC means that you're shipping the entirety of the TCC compiler with your executable, because your executable now need to be able to take a string, compile it, and execute it. So that means you have to literally ship the compiler with your program, along with your program, somehow bake it, somehow link into it, which is probably fine, right? So because the interpreter is usually shipped with every Python application, right? So if you have some sort of Python game that is written in Python and PyGame, you install that game, usually it also installs the interpreter. It cannot work without the interpreter. So yeah. And doing stuff like that basically blurs the difference between such languages as C and Python, right? There's a TCC run. As far as I know, what TCC run does, it literally just executes the executable after it finished compilation. I don't think these features are comparable. I don't think you can compare TCC run with eval. Though there is a thing in TCC called libTCC, and I think it's literally just that. It's like the compiler, right? So I don't quite remember. Let me take a look at the libTCC. So third party tinyc, so lib tcc.h, tinyc compiler. Right, so because there is a libTCC in here. Oh my god. libTCC. Yeah, here it is. TCC1 and so on and so forth. And yeah, so you can have TCC state. And I feel like so you can literally create new compilation context. You can create new compilation context you can add include. I think that's what it literally is, isn't it? And you can just, so link and run make. I think this is literally eval, isn't it? I think so. So if I do something like foo-c and I include libtcc.h and all right. So if I compile foo.c, seems to be compiling, but I'm not using anything in here. tcc new, I said. All right. If I try to create a new tcc context, and it's not going to work, right? So well, yeah, because we need to link with libtcc. Okay, libtcc.a. All right, and that works, and that creates me a context, right? So if I have hello.c, all right, so this is a hello, and then, so this is like a separate thing in here. Hello world. Hello world. Okay, and in libtcc, what do we want to do? You can include path. So maybe you want to add the file, or maybe you can even compile string, by the way. But let's actually add an entire file. So it returns an integer, maybe indicating that there could be an error, but I don't really care. So it's going to be hello.c. And we also can set the output. I remember seeing the output file. Okay, so here's that. So we provide the tcc, and output is going to be hello. And I suppose it's just a tcc run. Or can you just compile? I don't see the compilation. So link and run main function return as value. Do not call tcc relocate before. All right, so it's going to be tcc 1. Is that going to work? Yeah, so it has to be so argv. Probably have to put null in here just in case, but I mean I already supply the arguments anyways. So what do you want from me? It wants include stdlib.h. All right, so we get a program, right, that creates tcc state, adds this file, sets the output file, and then it runs it, right? Then it runs it. Is it going to work? It's segfaulted, so I don't know. Right, but I have an actually fucked up version of my tcc, so maybe that's fine. I don't know. I gave it a try. So, but it looks like from the interface, it looks like tcc just has eval. So, but I mean, again, like I did experiments on this code base. I don't want to spend any time fixing it right now. So, but yeah. And yeah, as already discussed multiple times, like the difference between compiled and interpreted languages starts to blur the more you think about it. The more you start to think about it, it's just like it's kind of the same thing. But what's the difference between C and Python then? What's the fundamental difference between them? Well, the official implementation of Python, like CPython, it doesn't really generate any native code. It doesn't have any JIT compilation, right? So C, at least it generates some native code. So I suppose at that point, the difference between languages is that one languages are slower, other languages are faster, or maybe you can differentiate them by how much control they give you over the execution environment, right? So Python gives you less control over the execution environment, because it basically sandboxes you in its own environment. C gives you more control, right? So yeah, that's a good one. So C targets x86, Python targets Python VM, right? So it's just like, I guess that's basically the difference between these languages now. If you go that philosophical. So yeah, we explored picoc. It was an interesting project, right? So I suppose the most fun came not from really the project itself, but from an opportunity to hack it, right? So it was kind of fun to hack this project, and yeah, I gotta give the props to the authors of this project. It was very easy to modify, right? So we quite quickly found a place where we had to put a hack to add support for const, for instance, and that's a good sign. That's a plus, right? So if modifying your project that easy, that's a huge plus. So overall, it's a really fun toy recreational project, but I don't think it is suitable for anything serious. So that's my conclusion so far. So you go give it a try. Maybe you can find something even more interesting in there. But yeah, I guess that's it for today for me. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you. Mwah.